My name is Keith Hare. Among other things, I'm the convener of something called SC32WG3. What I want to cover in this talk is a brief history of the SQL standard, talk a little bit about what's in the SQL 2016 version that was published almost 2 years ago, talk a little bit about something called the Technical Reports, which is actually a really useful resource, and then talk about what's next. And what's next are things like multidimensional arrays, streaming SQL, and strangely enough, there's interest in property graphs in the standard. So who am I? My day job is I've been a consultant in high-performance database systems for quite a few years, and we specialize a lot in replicating data between database systems. For fun, I've gotten involved in standards. I kind of have a weird sense of fun, and I've ended up being the convener, that is the chair of ISO, IEC, JCC1, SC32, WG3, which is responsible for database languages. And you're looking at that and saying, huh? I'll translate in a moment. And I'm also the vice chair of the US Standards Committee, and I've been involved in some of the big data stuff. Actually, I'm the vice chair of the US Big Data Technical Committee. I started off as the chair, and then I got a promotion to vice chair. And at some point years ago, I actually went to school. Now, one of the things about the computer industry is the technology we're using today didn't exist when I was in school. And so all of this, we have to continue to learn and to learn new things. Abstract, this is the words that got you guys to show up here. So what is SQL? Well, it's a language. You all heard of SQL. Probably many of you have used SQL. Maybe some of you have even written SQL databases. What does it stand for? In the standard itself, there is no definition. My friend Jim Melton claims that SQL stands for SQL Query Language. The important thing is that SQL queries are independent of how the data is actually stored. You specify the data you want, not how to get it. So it's a declarative query language. So who develops the SQL standards? Well, there's an international committee, and the officers, I'm the convener, which is a fancy word for chair, but at a working group level, they have conveners, not chairs. The editor is a guy by the name of Jim Melton, who currently works for a company called Oracle. In previous lives, he worked for a company called Sybase, and before that, he worked for a company called Digital Equipment Corporation. We have active participants from a number of countries around the world, and each of those countries have their own committees that feed stuff into the international arena. So the best way to describe this is a graph. So there are two organizations, ISO and IEC, and they have overlapping work, and they created something called Joint Technical Committee 1. And it worked out so well that, as far as I know, there's never been a Joint Technical Committee 2. Under JTC1, there are a bunch of subcommittees. The Data Management and Interchange is Subcommittee 32, and under Subcommittee 32 is Working Group 3, which is responsible for writing standards about database languages. Traditionally, we've looked at that as being SQL. Brief history. I'm going to spend the next 3 hours going through the feature of every release of the SQL standard. Right. But the thing to do is to look at this list and say, okay, this isn't static. The SQL standard has changed since 1987 or 1992, whatever version it was you last looked at. We've added a lot of things in various releases over the years, the most recent of which was SQL 2016. With any project, yeah, you've done a lot of stuff, and the question always is, but what are we doing now to meet the emerging market needs? SQL 2016 really had four major things. Row pattern recognition, the idea of being able to do regular expressions across sequences of rows. If I prepared, I could do about an hour on that topic. Support for JavaScript object notation, JSON objects, to be able to store, query, and retrieve JSON objects. And that's another good hour talk. Polymorphic table functions. The idea of a polymorphic table function is you can build a function where you don't know the shape of the return table or the input parameters until runtime. That's good for about 2 hours. And then we did some additional stuff, and the trigonometric and logarithmic functions, what we ended up doing is we ended up adding a bunch of things to the standard that every implementation was already doing. So we needed it for some other things, and that was just sort of a gimme. Everybody's doing it, we might as well put it in the standard. Here's the cheat sheet of all the parts. There's a total of about 4,000 pages in these documents, and it's exciting reading. Yeah, maybe not so much. It's really interesting once you get into it. Standards are interesting in a really boring way. We've also done some technical reports. What happens is, the way we work is people write change proposals with justification for the change and then the details of the change. Well, the details of the change end up in the standard, the justifications don't. And so over the years, we've started taking the justifications, the descriptions, the non-normative stuff, and putting it into technical reports. And there's a couple good things about this. One is that the technical reports are a lot more approachable, a lot more readable, because basically they include examples than the actual standard itself. We're up to 7 are published, and we have a new one that is in the works that hopefully will be, it's actually hung up in the ISO hierarchy, but hopefully by the end of this year it'll be published. So we've got reports on things like the row pattern recognition and JSON, and what we've started doing is when we add significant new features to the standard, we also write technical reports to explain it. Best part about technical reports is that if you go to the correct location, the JCC 1 site here, and you search for 19075, which is the part number we're using for reports, they're free. Now you do have to say that you're not going to pass them around to all sorts of people, but you can download them for free, and that gives you some really interesting resources about what's going on in the standard. Okay, so that's what we've done. What's next? Well, we've been working on something called multidimensional arrays. I'll give you a high-level view of that. We've been working on streaming SQL and working on property graphs. The idea of multiple dimensional arrays, the SQL standard prior to this part supports single dimensional arrays. But the idea of a multidimensional array is you can create an n-dimensional array where it has a single data type. And the only restriction really is that the data type has to be essentially a fixed length. So we don't currently support multidimensional arrays that are varchars or that are binary large objects. But for numerics or fixed length characters, we can pass them in and pass them out and whatever. And there's a couple of operators, MD array type and MD array operators. And basically, the work on this is all done except for the last final draft international standard ballot. And that should have started by now, but we're having a discussion with ISO in Geneva about some of the formatting stuff that they want that doesn't really fit the way we've been doing standards. So maybe by the end of this year, that'll be complete. So why do we want to support multidimensional arrays? Because then you can do things like do operations on images or seismic data or oceanographic data, and basically do the operation in the database on the server as opposed to having to pull the entire thing back and operate it locally. And so you can push the operations to where the data is, get back only the data that you're interested. which should reduce the network load. Also, it gives transaction support. I mean, it used to be that storage space was a limitation. Storage is cheap enough that it's less and less a limitation. Memory is cheap enough that that's less and less a limitation. And so if we can push these onto servers, add the transaction support, add all the database management capability, then there should be some real wins. Streaming data. Talked about Internet of Things and at various points, time series data, video, audio. The idea is that we want to be able to do continuous processing on a stream of data. Right now, if you do an SQL select, it selects stuff from query, and you get a set of data back. But what if instead of getting just back a set of records, you do a select stream from some input, and you can process records in the stream, and it goes on forever. And then maybe you can bundle that with some of the other capabilities and process the data and maybe output the data to other things. And if you had this capability, it might look, you might be able to map data that's coming in from something like Kafka or publish data to something. And you could take advantage of all of the capabilities that exist in SQL now, including queries, compound statements, stored procedures, row pattern recognition, JSON, XML, polymorphic table functions, multiple arrays. So the idea is to be able to use all of the capabilities that are now in SQL on data that is coming through continuously. And we're working on that, and potentially 2019, 2020. 2019 is highly optimistic. But what about graphs? Well, there's the existing graph language efforts. There's W3C has a specification for a query language called Sparkle and a web ontology language called OWL for a sort of simplistic graph, something called RDF, Resource Description Framework. There's some work in the property graph queries from something called the Linked Data Benchmark Council Query Language Task Force. Say that fast 10 times. There's the Open Cypher Project, and there are a number of vendors that are working on property graphs in particular. LDBC has some benchmarks and has been looking at requirements for a property graph language. The Open Cypher Project has been working on a declarative query language and has done some work. And Neo4j has been sort of involved in Open Cypher. But how does this all fit within SQL? Well, what our current discussions are is adding a new part of the 9075 that set of standards that defines ways for the SQL language to process property graphs and interact with them. We're currently looking at read-only access to property graphs, a concept called a graph table function, where essentially you have a graph table function and the graph part of the query is within that graph table function, it returns a table. There's some work that's been done on specifying how graph pattern recognition and a few other things that are in process. And maybe eventually it may make sense to actually within SQL to be able to do graph construction and graph update. That's still under discussion, still to be decided. An example of graph table that I swiped from a recently posted paper that we will consider at our next WG3 meeting at the beginning of October. This is coming out of the US from a guy by the name of Fred Zemke, who works for a company called Oracle. But I know the Neo4j have been in on discussions of all of this. So why integrate property graphs with SQL? Well, turns out that users are using both SQL databases and property graph databases. And application development in theory should be easier, better, quicker, faster if there's only one interface. And it may be that there are some types of queries that are better done as a property graph query than as an SQL query. There's some types of queries that are better done as an SQL query. And so we think there's a benefit in merging the capabilities into SQL. So when will it be real? We should have a working draft by the end of this year, a pretty good working draft of the property graph queries. What we're calling it is SQL/PGQ, and it's going to be part 16. If we do that, there's a good shot that we can actually have an official standard by 2020. There's a whole set of things that we've been referring to as SQL 2020, and this is part of it. Now, along with the work in the standards group, the database vendors are not standing still. Database vendors are adding graph support, property graph declarative language support to their products now. So that, if you look at that, the graph table example is sort of a limited. We can query graphs within an SQL table, but what about a full-blown graph query language standard? How would this fit into everything? What could we do? Could we build a declarative query language standard for a property graph query language? And how would that different? How would that work? How would that be different? How could that work together with what we're doing on the SQL PGQ stuff right now? Well, earlier I showed you a list of the parts. The SQL framework part has some base stuff that's used by all the other parts. SQL Foundation has most of what you think of as SQL, including things like data types, specification for transactions. There's a part called SQL Schemata, which is the schema information tables. And so the thinking at the moment is that there'll be probably a part that is sort of the framework for GQL, the groundwork, that is common information that that's common both to the PGQ part, SQL PGQ part, and to the GQL proper. And the GQL groundwork can reference and include the parts of SQL Foundation, for example, data types, operations on those data types, et cetera, all the things that are not specifically relational that a graph query language can take advantage of. So rather than building a whole brand new standard that defines operations on integers, we already have all that definition in SQL Foundation, and we can take advantage of it in a GQL standard. So what might fit into this? In GQL proper, the graph capabilities that are not needed by the PGQ, in the groundwork or framework, whatever we manage to call it, the capabilities that are common to both the full GQL standard and to the SQL PGQ part of the standard. So we can take advantage of things that are there in framework, mostly the conventions and possibly the conformance model, the scalar data types, operations, functions, the transaction model. One of the questions that we need to look at is right now the SQL standard deals in terms of what's called an ACID transaction model. In some of the NoSQL databases, there's a concept called a base transaction, and we need to look and see, is there anything there that makes sense to add? Does the transaction model fit with everything you're going to do in a graph database, or do we need additional capabilities? Security model, maybe the model for describing the client and the session. Some of this is needed for SQL PGQL, and so what we probably will end up doing is adding it to SQL PGQ 2020 and then splitting it out later into the separate groundwork document. But very few people are going to care about the details of that. Then there's going to be the things that are graph only, things like vertices and edges and path operations and so on, and maybe a graphical analog of the schema information tables. What's that going to look like? I don't know yet. That's going to be interesting. So when will this be real? A lot of the discussions on this are going on in something that's called the Property Graph Ad Hoc, which is a subgroup of the US committee, DM32.2. And it's chaired by a guy by the name of Jan Michels, who works for a company called Oracle. It has participation from vendors, from consultants. Occasionally we get people from the LDBC GraphQL task force participating in the meetings. And the work is beginning to bubble up out of that through DM32.2 to SC32WG3. There'll be a quiz later on all these relationships. And I expect at least Stefan to pass it, Stefan. But we're going to do the SQL PQL first. Going to get that done. So the real thing is it depends on how much time the participants have to put into this. Because building a standard actually takes a lot of time. It's a fair amount of detail, a fair amount of picky, low-level detail, and it takes time and it takes input from participants. But I'm really psyched about this because it looks like we're going to have that input from participants. So a possible timeline might be that we get, for the GQL, we have an initial outline of a working draft. There's a potential W3C workshop on graph data, and I'll talk a little more about that later, and so on and so on. I outlined this timeline, and it's fair to say that this timeline is highly speculative and very optimistic, and it depends on a lot of work that hasn't been done yet, and it's work that I'm not going to do, other people are going to have to do. So I can speculate about the timeline. I can't make it happen without a lot of people doing a lot of work. I mentioned a W3C workshop. Well, there's an idea that there might be a W3C workshop on web standardization for graph data with the subtitle of Creating Bridges, RDF, Property Graphs, and SQL. So we're actually talking to various players in various forums. The idea of this workshop is to get input from people that are in the W3C, input from people that are in the open source community, input from people that are in the ISO standards community. And it might happen the last week of February in Berlin, Germany. Now, this workshop is in planning. There are a few details that haven't been finalized, including W3C approval for the workshop, the actual venue, and the actual date. So I think it's going to be a really interesting workshop. I think it's going to happen, but you may not want to book your plane tickets just yet. That should happen in the next, all those things should fall into the place in the next month or so. Okay, so we got all of this going on. SQL standards have a fairly long history. In the standards world, we have a long history of incorporating data, incorporating technology, incorporating new things into the SQL standard. So just in the last edition, we added row pattern recognition, JSON, polymorphic table functions, analytics. We've completed, except for the final approval, the support for multi-dimensional arrays. We're looking at streaming SQL. And actually, streaming SQL is kind of interesting because there have been some mention this week of doing property graph work against streaming data. And so if we can complete the work on streaming SQL, then a later edition of the property graph work can incorporate streaming property graphs and take advantage of the capabilities that the specifications we do for streaming SQL. And we're looking at a brand new database standard, database language, a graph query language. Any questions? Yes?
When you are implementing this graph-like query against your relational tables, is the plan to port this into a SQL query? Is it essentially like a layer above SQL, or are you somehow directly hitting the tables?
Okay, so the question is, when you're doing these graph queries, well, the first, against existing tables, the first piece that's being added to the specification is a function called graph table. And what that does is it takes a property graph query and returns data that looks like a table. Now, somewhere in the works, and I've lost track of where this is, was the idea of being able to create a view on top of existing relational tables that make them look like property graphs. And I don't remember where that sits, I know we've talked about it, I don't know that anybody has actually written anything to actually do that. But ultimately, it'd be nice to be able to do graph queries that return data as a table, views against underlying tables that return data as graphs that can then be queried, and return data as a table. When we get into the full graph query language, it'd be nice to be able to have the full graph query language operate against essentially views against the underlying table. I mean, part of the reason for doing all of this is that there is a lot of data that only exists now in SQL style data. There's a lot of capabilities that can be implemented with graph queries. And so we want to be able to be everything to everybody, but there's still be a little bit of work to be done on that.
Can I just comment on that?
Go ahead, Jim Steiner.
To some extent, the standard and the implementations really do depend on the vendor's business. So, the standards could be standards to specify the standard. Whether the vendors implement true graph structures in a multi-model environment, or whether they implement on graph databases, or whether they put graph views. Now, if there's a standard for how a graph view is defined, like
right.
have an RDF, we can put an RDF view on things. That could be part of the standard as well. But the implementations are a little bit of both, right?
I misunderstood this as an implementation, but this is a description of the standard as well.
Right. I'm a standards guy. I don't implement SQL. This is.
Participate in this activity will be saying, yes, this is practical, it can be implemented, it gives us the flexibility to do these kinds of things.
Here, Alistair, I'll hand you a mic. That could be dangerous.
I'm not sure I need a mic actually for a room this big, but I think the idea that's being discussed is that it would be possible to define the schema effectively of a graph and have no relationship to underlying tables, or to be able to map such a schema to underlying tables. And either way, you'd be able to run graph queries over the graph definition. So there would be freedom for implementers to decide, is this a native graph database? Is it on top of an existing SQL database? And the standard would just give you the tools at the sort of interface level. Yeah.
Right. Is it additional models inside an existing database, so those kinds of things? So that gives you all that time. Or is it a streaming structure?
Yeah. So yeah, I'm looking at everything from the standpoint of the official standard that will be adopted as an ISO, IEC, JCC1 standard. And then it's a matter of vendors actually implementing what's in the standard or something close to it. And a lot of the specifications are being contributed by the vendors. So there's a good chance that when we get done, what's in the standard will be really close to what the vendors are doing. Yep. Any other questions? All right, thank you.